Hi students, good morning. Welcome to Business Mathematics class. Last class we have learned the first section, rank of a matrix. We are going to continue the next section, elementary transformations and equivalent matrices. Before that, I hope you all completed the last day's home assignments. Okay, let's move to the today's section, elementary transformations and equivalent matrices. This elementary transformations and equivalent matrices both are new to you. So first I will give the definition for elementary transformation and what about equivalent matrices. Understand? Okay. You take a book and refer in your book. Okay. First one is elementary transformations and equivalent matrices. Definition for elementary transformations of a matrix. Okay, there are three steps. First one is elementary transformation means interchange of any two rows or columns. Okay, so any two rows or columns you can interchange. I will give one small example how to interchange the row and column. Let us take one 3 by 3 matrix. Okay, 4, 5, 6, 7, 8, 9. This is a 3 by 3 matrix. So, first step I said to you, we are going to interchange the any two rows or columns. That is elementary transformation. Okay. Now, this is R1. That is row 1. This is R2. This is row 2. This is R3. You know it, right? This is column C1. This is C2 and this is C3. So, as per your wish, if you need to interchange R1 and R2, you can do. How you will interchange? I am going to interchange R2 and R1. So, wherever this R2 row fully you need to change as R1. So, 4, 5, 6, same as 1, 2, 3, 7, 8, 9. Now, I have interchanged R2 and R1. Same as that, columns you can interchange. Same as R2 and R3 also you can interchange. This is first one. Okay. Then next one is multiplication of each element of a row or column by any non-zero scalar. That is, I am giving in the same example. Now I said multiplication of any non-zero scalar. If I am going to multiply, that is R2. This R2 row I am going to multiply by 2 into R1 means, don't forget we need to multiply that particular 2 by the whole row. Okay, by the whole row. If we need to multiply with the 2 means you need to multiply this number with 2, you need to multiply this number with 2 and this number by 2. So when you are multiplying by certain number, you need to multiply with that non-zero scalar with the whole row. That's the second one. Understand? Then come to third one. Addition to the elements of any row or column, the same scalar multiples of corresponding elements of any other row. So here itself they gave Ri implies. If you are taking in the I place as R1 means R1 implies R1 plus something K, maybe 2 into. Okay, that is R2. Like this we can change. Okay, so R1 implies R1 plus 2 into R2. This only they have give as a explanation. Okay, now you will get some idea. When we are doing the problem, you will understand. Okay, then next one is equivalent matrices. So two matrices are said to be equivalent if one is obtained from the other. That is, if I am multiplying or adding or anything, if I am doing by using the elementary transformation. Next step, I will give one small example. That is, this is a matrix A. Okay. Now, I have interchanged R2 and R1. Is it right? And I have obtained the next one matrix. That is 4, 5, 6, 1, 2, 3, 7, 8, 9. So, these two matrices are equivalent matrix. That only. So, A is equivalent to B, same as B is equivalent to A. This is a symbol for equivalent. Understand? So, when you are interchanging or when you are multiplying by any scalar, that is, if you are transforming, that is elementary transformation, after that when you are obtaining a matrix, that particular matrix and this matrix both are equivalent. So A is equivalent to B, same as B is equivalent to A. That's the meaning of equivalent matrices. Understand? Okay. Next one is echelon form and finding the rank of a matrix. Okay. This echelon form and finding the rank of the matrix, it is possible only for up to the order of 3 cross 4. If a matrix of order 3 cross 4 up to the order of 3 cross 4, it is we can apply. Okay. So just I am reading the definition. When we are doing the problem, I will explain what is echelon form. Okay. A matrix A of order m cross n is said to be an echelon form if every row of A which has all its entries 0 occur below every row which has a non-zero entry. The number of zeros before the first non-zero element in a row is less than the number of such zeros in the next row. Okay. Just I am giving one matrix in the echelon form and I will simply explain. When we are doing the problem, I will give the clear explanation for you. Okay. Okay. I will give one example for you. That is, you see this. I wrote this matrix in a echelon form. Again I am rewriting. That is 1, 2, 3. Okay. So next one is 0, 0. How means for making the echelon form, you need to check first entry. That is, if it is a 3 by 3 matrix, the first entry must be non-zero. That's the first condition. That is first entry. That is here the first entry is 1. Is it right? Maybe any number 2 or 3 or 4 or anything. It would not be 0. Okay. Always it must be any one of the number. Okay. So below this entry, all the entries must be 0 in echelon form. Okay. Before that is 1 is there. So below this entry, all the entries must be 0. Understand? So next number I am writing is 5. If it is 5 means below this number also be 0. Okay. Maybe here 3 or okay, here it is 3. Then down here this entry may be 0, may not be 0. Okay. Then when we are doing the problem, we come to know. So you keep it in mind. This one must be any one of the number. Then below this one, all the entries must be 0. Then you check the next entry. If it is a number, then down this also 0. So you come to know in that last row, here it is only one entry as 0 means here 2 must be 0. Maybe 3 also it will be 0. Okay. So when you are doing the problem, you will get the clear idea. This is echelon form. Okay. Let's move to the question. Find the rank of the matrix A is equal to 1, 2, 3, 2, 3, 4, 3, 5, 7. Okay. So, same as our last section, we will find the order first. Okay. So, what's the order of this matrix? The order, here we no need to take let A is equal to, because already it is given as A matrix. So, the order of A is how much? How many rows and how many columns are there? 3 cross 3. Okay. So, therefore, row of A, how much? How many? I said this, it right already. 3 cross 3. So, it is the order is 3 cross 3 means always the rank value row of A must be less than or equal to 3. This one already you have learned. Okay. So, next we are going to do by elementary transformation. Okay, that section only we are learning now. So, let us transform the matrix A to an echelon form. We want to transform this particular matrix to echelon form by using elementary transformation. Understand? So, let us transform. Let us transform the matrix A to an echelon form. By using elementary transformation. Okay, listen here very carefully. First we need to check the order. Now you got the order row of A, that is 3 cross 3 is the order of A. So row of A must be less than or equal to 3. That one already we have learned. So this problem we are going to do by using elementary transformation. So let us transform this particular matrix A to an echelon form. You need to change to an echelon form. Now I explain what is echelon form. You will get some idea, but when we are doing the problem, you will get the clear idea. Okay, so listen here carefully. Okay, listen here. So it is a given matrix A. Okay, so I am going to write the matrix here. Whatever the elementary transformation I am going to do, I am going to note here. Okay, first I am writing the matrix A. So what is A? 1, 2, 3, 2, 3, 4, 3, 5, 7. This is a given matrix. Okay, so I said that is first entry we need to check. That must be a number. So here it is no problem. It is a number. Okay, so I said you need to make all the down entries. That is 1 is a number. So below this 2 entries are there. Here see, this is 2, this is 3. So first you need to change this 2 numbers as 0. How you will make is, I am going to do this elementary transformation to change this. How means R2 implies R2 minus 2 into R1. Okay, this R2 row, I am going to change this R2 row as R2 minus 2 into R1 I am going to do. Okay, listen. So this is equivalent to, this is a symbol for equivalent to first row as it is. That is 1, 2, 3. Second row what I am going to do? R2 minus 2 into R1. So here R2 is 2 minus 2 into R1. Each and every element you need to do. So 2 minus 2 into R1. Understand? 2 minus 2 into R1. If you need, you can write it on the rough work. That is 2 is there. R2 minus 2 into R1 value is 1. So how much you will get? 0. Understand? Now we made this entry as 0. Understand? So likewise you want to think and you want to do the elementary transformation. Whatever the elementary transformation if I am doing means I will get this 2 entries as 0. You want to think and do. Understand? So this entry is now 0. Again next term also you need to do the same procedure. So 3 minus 2 into R1. So 3 minus 2 into 2, that is 4. Is it right? So 3 minus 4 means minus 1 you will get. Then next term 4 minus 2 into 3. So 4 minus 2 into 3 means 6. So 4 minus 6 means minus 2 you will get. Understand? Then next R3. Here also you know, is it right? This entry you need to make as 0. So here it is 3, is it right? So 3 minus 3 means this entry will become 0. So what will I will do? R3 minus 3 into R1. If I am doing like this, what it will happen? This entry will become 0. So R3 minus, so 3 minus 3 into 1. So how much? 0. Then same as next one. 5 minus 3 into 2, 6. So 5 minus 6 means minus 1 you will get. Is it right? Then next 7 minus 3 into 3. So 7 minus 9 means minus 2 you will get. Okay. So this is second one. Then next I said, then also you can try. Why means here this 2 entries we have made as 0. Is it right? So maximum in the last row, maximum number of zeros must be there. Okay. So you want to see from this side. Don't see from that side. Okay. So maximum you need to try this last row elements as 0. Now if you see this matrix you come to know, is it right? Minus 1 is there. So minus 1. If you are adding with again minus 1, what will happen? Minus 1, minus of minus 1, this term will get 0. Is it right? So minus 2, minus of minus 2 means again this term will get 0. Okay. So 1, 2, 3, R2 row you won't do anything. 0, minus 1, minus 2. Third row what I am going to do to make all the entries as 0. Okay. So R3 implies R3 minus R2. Understand? So 0 minus 0, 0. Okay. So next minus 1 minus of minus 1, 0. 2 minus 2 minus of minus 2 means this also 0. Now we can check this matrix whether it is in echelon form. That is first entry is 0. Okay. Then next one below this entry all the entries must be 0. Okay. So here in the second row only one entry is 0. But in third row the 3 entries are 0. If it is some problems we can't make all the 3 entries as 0. Okay. So The main thing is first row, that is first column, that is here it is 1 means down the 2 entries must be 0. Then you want to see the next number. If it is -1, here it is -1, then that down entry also must be 0. Okay, maybe this is a number or may not be. It is 0 or maybe any number, both also correct. But in this problem we got all the entries as 0. Then now this is in the form of echelon form. Understand? Now this matrix is in the form of echelon form. It is in the echelon form. It is in echelon form now. Now the number of non-zero rows. Okay. Now shall we check here how many number of non-zero rows are there? Non-zero. So here all the entries are 0. So we will leave that. Is it right? So in this second row, 2 entries is a non-zero. So that's also a non-zero row. If it is a 0 row, if all the elements contain 0, we'll leave that. So non-zero row, how many non-zero rows are there? 2 non-zero rows are there. So number of non-zero rows is 2. So what's the rank of this particular matrix? Number of non-zero rows is 2. Therefore rank of A is 2. Therefore we will conclude row of A is equal to 2. Understand? I hope you got some idea. Okay. Next problem, example 1.7. Find the rank of the matrix A is equal to 0, 1, 2, 1, 1, 2, 3, 2, 3, 1, 1, 3. Okay. So first we will find the order of this A. Okay. So solution, order of A is, how many rows are there? 3 rows and 4 columns are there. I said, is it right? Minimum of order of A you need to choose. Is it right? Sorry, minimum of 3, 4 you need to choose. So row of A value is less than or equal to 3. Maybe 3 you will get, otherwise less than 3 you will get. Okay. So now I am going to transform this particular matrix to echelon form. Understand? Okay. So here it is matrix A. Here I am going to do the elementary transformation. Okay. Elementary transformation. Okay. So first I am going to write the matrix 0, 1, 2, 1, 1, 2, 3, 2, 3, 1, 1, 3. Okay. So it's the matrix A. You want to check the first entry. That's the first step here. So now see here, first entry is a 0. I said already, is it right? First entry must be any one of the number. It won't be 0. So first you need to interchange R2 and R1 to make this entry as number. So I am going to interchange R2 and R1. So R2 will come to R1. That is 1, 2, 3, 2. This will come here. So 0, 1, 2, 1. 3, 1, 1, 3. Understand? Okay. Next, this is equivalent to. Next, what will you do? Here see, it is 1. Down it is 0. So no problem. You need to make this 3 as 0. So you need to change this R3. Okay. So first row and second row same. 1, 2, 3, 2, 0, 1, 2, 1. I am going to change this one. Okay. R3 implies, that is here 3 is there. Is it right? So R3, if I am making this as 3, so R3 minus 3 into R1 means I will get the answer as 0. So that's what I am going to do. So R3 minus 3 into R1. So 3 minus 3 into 1 means we will get 0. Then 1 minus 3 into 2 means minus 6. That is 1 minus 6 means minus 5. Okay. Then R3, that is 1 minus 3 into 3. That is 1 minus 9 means minus 8 you will get. Yes. Then next one. 3 minus 3 into 2. So 3 into 2 means 6. So 3 minus 6 means minus 3 you will get. Understand? Okay. Then next, I said, is it right? Now this column, okay. The next one is a number, okay. So down entry must be 0. So you keep it in mind, you need to make this minus 5 as 0. Then only this particular matrix will change to echelon form. So how you will make this minus 5 to 0? How we will change means R3 implies R3 plus 5 into R2. That is, here it is 2, is it right? So, if I am making this R3, that is minus 5 plus 5 into R2 means this entry will become 0. Understand? Symbolize first row and second row same. 1, 2, 3, 2, 0, 1, 2, 1. Okay? Okay? There are two chances. That is R3 implies R3 minus, if I am changing, otherwise this also you need to change, is it right? So it is difficult. Otherwise you can do one idea. R3 plus 5 into R2. Okay, 5 into R2. Shall we check? That is R3. R3 it is 0. So 0 with, if you are adding anything we will get 0. That is, you keep it in mind, if I am taking this as R1, what will happen? 0 plus 5 into R1 means again you will get the number here. So it is wrong, is it right? So I am choosing this 2. Okay. So how it will happen? R3 plus 5 into R2. So 5 with any 0 means we will get again 0. The next one. Minus 5 plus 5 into 1. So how much will get? 0. Then minus 8. Minus 8 plus 5 into 2. So 10. So minus 8 plus 10 means we will get 2. Again minus 3 plus 5 into 1. That is 2. Understand? This is the form of echelon form. This is an echelon form. Shall we check? First entry is a non-zero entry. Okay. Down below this entry all the entries are 0. Okay, then we will go to the next non-zero entry. Below this entry that must be 0. Okay, if there is a chance, here itself it will last problem, same as last problem, this entry will become 0. Otherwise no problem. So now you can check. Maximum zeros are there in last row. Yes. Now how many non-zero rows are here? How many non-zero rows? This is a non-zero row. This is a non-zero row. This is also a non-zero row. Reason is here 2 is there, here 2 is there. So, number of non-zero rows. Number of non-zero rows is 3. What's the rank then? Row of A is equal to 3. I hope you got idea. If you are doing one more problem, you will get the clear idea. Okay. Let's move to the next problem. Example 1. Example 1.8, find the rank of the matrix A is equal to. So first we will find out the order of the matrix. Okay. So order of A. How many rows and how many columns? 3 rows and 4 columns are there. So 3 cross 4. So row of A value must be less than or equal to 3. Is it right? Now we are going to change this particular matrix to echelon form. Okay. So matrix A, then elementary transformation. Okay. So first I am writing the given matrix, that is 1 1 1 1 3 4 5 2 2 3 4 0. Okay. So first we are going to check. First entry is a non-zero, so no problem. Equivalent to 1 1 1 1. Okay. What I said, below this the 2 entries must be 0. So I am going to change this R2 as R2 minus 3 into R1. So if you are multiplying this with 3, you will get 0. So 3 minus 3 into 1, 0. Then 4. 4 minus 3 into 1, 4 minus 3 means 1. Then 5 minus 3 into 1, 2. Then 2 minus 3 into 1, that is minus 1. Then this one you need to make a 0. Yes, R3 implies, so R3 minus 2 into R1. If you multiply this with 2, then 2 minus 2 you will get 0. So this will become 0. Then R3 minus 2 into R1. First itself I said, don't see from this side to this side. This here, see, last row, this entry is 0. That's no use at all. From here to here, you need to make maximum zeros. Okay. Then R3 minus 2R1. So 3 minus 2 into this one means we will get as 0. Yes. Then Next, R3, 4. Is it right? 4 minus 2 into R1. That is 4 is there. So, how much you will get? Sorry, R3 minus 2 into R1. So, R3 is there. 2. 2 minus 2, that is 0. The next one, 3 minus 2, that is 3 minus 2 means 1. Then 4 minus 2 into 1, that is 2. Then next, 0 is there. So, 0 minus 2 into 1, that is minus 2. Understand? Then, now you see this 2 entry is 0. Okay. Then what will you do? You will check for next non-zero. This is non-zero. Down, it is not equal to 0. So, you need to make this 1 as 0. You need to try for that. That is 1, 1, 1, 1, 0, 1, 2, minus 1. Okay. You need to make the next this as 0. So, R3 implies, if I am making R3 minus R2, what will happen? R3 minus R2, 0 minus 0, 0, 1 minus 1, 0, 2 minus 2, 0, minus 2, minus of minus, that is plus, that is minus 1. Understand? Now you can check. First entry is non-zero, below that 2 entries are 0. Is it right? Maximum number of zeros are in last row. Second non-zero element is there, down entry is 0. Now it is in the form of echelon form. So how many non-zero rows are there? Number of non-zero rows. Number of non-zero rows. How many? 3 non-zero rows. Here non-zero row. This is also a non-zero row. This is also a non-zero row. Why? Here one element is there. So non-zero row is 3. So, row of A is equal to 3. How many? Row of A is equal to 3. These are the 3 example problems given in your book for this section. I said you already, exercise 1.1, already I gave first Roman 4 problems for your homework in the last class. So, remaining 4 problems are there. This remaining 4 problems you need to do in this elementary transformation method now itself. Understand? I think you got some idea. Today we have learned elementary transformation and how to make a matrix into an echelon form. Okay? You go through these 3 examples and afterwards you take your home assignments. Already you have completed first section 4 problems by using the last section method. So remaining 4 problems are there in the first section. So that 4 problems you need to do by using this elementary transformation. You need to change the particular matrix into echelon form by using elementary transformation. After that, find out the matrix. Okay. I hope you got idea in this section. Okay. These are all the section in. These are all the things in second section. Okay. Let's move to the next section. I will give the definitions alone today. Next class we will continue the problems. Okay. Now you take down your books. Okay. Our next section is consistency of equations. Consistency of equations. System of linear equations in 2 variables. This is not new for you. Reason is last year you have learned this same. Okay. System of linear equations. So last year you have learned linear equations means you know it's a degree 1. Is it right? It is in the form of ax plus by is equal to h, cx plus dy is equal to k. I will give one small example. That is x plus 2y is equal to 4. 5x plus 5y is equal to 2. Okay. Now how we will write this one? We will write in the form of ax is equal to b. This one already you have learned ax equal to b. Is it right? So next step what will you do? X is equal to a inverse b. Like that we will change. Provided determinant a value not equal to 0. This everything you have learned in last year. Understand? So this year what we are going to do is we are going to study this year testing of consistency. We are going to learn testing of consistency of a non-homogeneous linear equation 2 or 3 variables by using rank method. This rank method is new for you, then this consistency is new for you. Okay. So you come to know rank method already I have taught you. Then consistency. What's the meaning of this consistency? We need to know. Okay. For that 4 notes are given in your book. That is very important. If you are very thorough in this 4 notes, this next section is very easy for you. So show that the equations are consistent, show that the equations are inconsistent, show that this particular equation is inconsistent and has unique solution, show that the particular equation is consistent and have infinitely many solutions. Like that the questions may be. Okay. So, first one is if row of A comma B is equal to row of A, then the equations are consistent. Next, row of A comma B is equal to row of A equal to n, then the equations are consistent and have unique solution. If row of A comma B is equal to row of A less than n, then the equations are consistent and have infinitely many solutions. Row of A comma B not equal to row of A, then the equations are inconsistent and has no solution. Okay, these 4 rules you want to by heart. For that only today itself I am giving. So when we are meeting in the next class, I will give the problems using these rules. Okay, so you by heart these 4 rules. Understand? That is both also equal means consistent, both also equal to n means consistent and has unique solution, both also equal to less than n, both also equal but less than n means consistent and has infinitely many solution, both also not equal means inconsistent and has no solution. Understand? This one you learn, you will get some idea when we are doing the problem, you get thorough idea in this section. Understand? I hope you all got it. We will meet in the next class. You will do the homeworks properly. First itself start to learn. Don't leave anything. Thank you, students.